This ladder has lost two of its lowest rungs there. I'm going to replace those with those two pieces of wood that I ran through the thickness planer to be the exact thickness that fits the width of the groove in the side rail there. This ladder is old. It's got multiple signs, at least 30 years old, multiple signs of structural failure. That rung is split there, it's wobbly there, it's missing another chunk of there, a huge portion of the rung at the back side, so the third rung isn't in a good condition either. The fourth one is also splitting everywhere. The fifth one isn't too much better either, so it's got multiple structural problems. Ladders are expensive, and I want to stay with this shape of the ladder. This isn't the sturdiest way to build a ladder, isn't the strongest way to build a ladder, but is the lightest way to build a ladder. That's why I want to stay with this shape. So, in a set of 3 videos, I will show you how to make the 3 angled cuts that are needed for fitting the rungs on a ladder such as this. These 3 angled cuts will be, one of them is gonna be the end cut for the rungs, because the side rails on this ladder aren't parallel, so it's not a 90-degree cut. The side rails are tapering, wider at the bottom, narrower at the top, so they're tapering. This isn't 90 degrees here. That angle needs to be cut. The second video will be dealing with this angle here at this isn't a 90-degree corner either, because the front end of the rung, or the nosing of the rung, has this angle on it. It's fairly straightforward to envision it. The third cut will be a support block that goes underneath the rungs there, because these bearing surfaces are rounded off and chewed up, and yeah, this side is even worse, so I'm not too happy with those bearing surfaces. I'm gonna have a support block here made that has this angle in it. One way to get the angles is a bevel gauge. You can just set a bevel gauge and get the angles that you need, just like so. It's fairly straightforward, but I'm not going to be using a bevel gauge. This works. It's a numberless type of measurement. You just set it to whatever angle you need there, and something like that, and tighten it, and then copy the angle. However, this copies the imperfections of the wood as well with it. If this rung has a camber, or curved a little bit, or has other problems with its shape, that's gonna be affecting some of these measurements. So I'm gonna use something else for this video. I'm gonna work with the overall shape of the ladder, its height and its span, just a couple of measurements, and one calculation on a scientific calculator, because we're gonna be using these trigonometric functions there, sine, cosine, tangent. Very straightforward, just one calculation, takes about 15 seconds to do, but I'm going to be relying on a tape measure instead of a bevel gauge to get the angles right. So let's get to measuring and calculating. For the second and third calculations, we need 2 more numbers that I set up here for measurement. For both angles we need just 2 numbers, the same 2 numbers, so after this there's no more measurements. So whether you're calculating the angle for the nosing on the rung, or you're calculating the angle on the rail, it's the same 2 measurements that are needed for the calculations. What I set up here, a level, a square, and a plumb bob. Let me explain here. The ladder, looking at it from the side, is one big triangle. It's got an apex up top here, and it's getting wider and wider and wider, and it's widest on the ground between the 2 rails, or 2 legs on the ladder. The plumb bob is splitting this big triangle into 2 right angle triangles in the middle. I found the apex by just simply extending the underside of the rail with a felt pen to that point there, and the other rail to that point there, and I'm just hanging the plumb bob in a manner that it comes down from that apex. Once the bob steadies itself, it's gonna be along the square line, along the square there, somewhere where the square is placed. That's where it's gonna come to a stop. From that square edge, we just need a measurement all the way to this point here. Why the level is on the ground here is because it's an old ladder, and we want to make sure that the rail at the back and the leg at the back and the leg at the front do actually line up. Now the plumb bob is not going to line up with the legs, because remember, the rails are tapering from the bottom closer to the top. Now from the previous calculation we know that the amount of taper is 121.5 millimeters, so you make sure that the plumb bob is actually 121.5 millimeters in from the square corner there. If you have to, push the top a little bit over, because it may not be leveling itself fantastically well, so make sure it's all symmetrical. Once it's done, what you need to do is take a straightforward measurement. Let's see if I can. Yeah, I can kind of do this. Of course, you need to hold the square on the ground there and just pull the tape measure and measure all the way to this point here. My measurement is 540 millimeters in this case. Now, the plumb bob is not in the middle. From here to here I got 540 millimeters, but from here to there I only have 370, something like that, because these are not two identical right angle triangles. The plumb line does split the ladder's triangle into two right angle triangles, but this distance here is longer than this distance, so that means that the rail at the back, or the leg at the back, is steeper than the rail that you grab for climbing, or where the rungs are housed. The reason for it is so that the ladder is more complicated. The manufacturer makes it so it's harder to copy or repair, and you spend some more time and money on buying it or fixing it. Preferably, yeah, just buy a new one. Make me some more money. So that's one measurement there, 540 millimeters, and wherever the plumb bob's tip is, you just measure up vertically, very straightforward. I have another measurement, 1702 millimeters, or exactly 67 inches, not coincidentally. This is an inch based ladder, but I like millimeters. So with those two numbers we can do the last two calculations. Now the third angle that's needed for this ladder project is fairly easy to calculate. In this segment I'll show you two ways to calculate it. One way will be relying on a previously calculated angle, and the other way will be relying on a previously taken measurements. So we'll be using the tangent function again. This angle gets used at two places. It's on the support block, along which the support block meets the rungs, and this is how it looks like. If I can get you a visual, I already laid out the angle on this support block, and over here I have a ladder rung with its nosing angle cut on it already, and this is how they will interact, the two of them, along which this angle, the cut will be made, of course. When this is how it's going to look like, and when the cut is made, of course, the support block will be underneath the rung, and of course this also needs to be cut to width. But so this is the angle that needs to be calculated, and this is one of the places this gets used. And this angle that's there, it repeats at every single rung. So further down, that's the end of the support block, and this is the same angle there as it is there. It's fairly easy to see. Now the other place where this one gets used, and let me just use the same piece of wood for show and tell here. This is the side rail now of the ladder. This is what you grab for climbing, and you have the rungs on it, so you step, 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 step. And if I can use this piece of wood for representing the ground, the side rail needs to be cut along this line as well, because this is the angle along which the rail will meet the ground. So this is when the ladder is open. This is the side rail. Again, this is what you grab, so you go up this way. So it's the same angle, okay, the same one angle. That's also why the title is rail angle calculation. So the support block and the rail end have the same angles. Come on in closer, let me just draw you a little picture of this. Now, a ladder rung, I'm gonna draw a ladder rung this way, as if it had a square nosing there, uncut, and the angle is there. That's the angle that we need. And if I can draw one more ladder rung there, so there it's the same angle. And of course, if I can do this line here, which represents the horizontal, then this piece of wood here is just roughly there for the side rail. So this is the same angle. These are congruent angles. This is fairly straightforward here. So first calculation, relying on a previously calculated amount. Let me just draw a reference line here for the vertical, and the previously calculated angle was here, this angle here. This angle from the vertical was 17.9 degrees. And I want to point out that this angle here and this angle here, they together make 90 degrees. Alright, because we're going from the vertical to the rail, and from the rail to the horizontal. So from vertical to rail it's 17.9, and from rail to horizontal that's going to be 90, because these two angles are complementary. They make 90 degrees together. So it's a simple subtraction situation here. It doesn't even need a calculator. 72.1 degree is the final answer for the angle on the support block as well as the rail's end. So this is calculation 1, relying on the previous measurements, and calculation 2 would rely on previous measurements that we took. And for this, let me just jog your memory that we had one measurement vertically here. This was 1702 millimeters, and another horizontal measurement 550 millimeters. Again, we're calculating this triangle here. If I can cross hatch it a little bit, because this triangle, right angle triangle, is not the same as this triangle, right angle triangle. You can see the number of squares aren't the same, because the pitch or the slope of this line and this line aren't the same. That's how the manufacturer made the ladder. So it's a headache to fix it or copy it or make angles on it. So if this is the angle that we are looking for, we're using the tangent function again. What we have given is a side that's adjacent, or in English next to, that angle, and then we have another side here that's opposite that angle. And this will be the opposite side, 1702. And likewise, previously, the tangent of an angle is expressed by the ratio of these two sides, opposite side divided by the adjacent side. So on a calculator I'm going to need to divide 1702 over, or divided by the 550. I'm going to have to put it in a bracket, and it's a second function tangent calculation, because we're looking for the angle. And this is how it looks like. Second function tangent bracket 1702 divided by 550, close the bracket, equals 72.09. So that's 72.1. there, exactly the same number, because 17.9, it's this number is already rounded, so therefore that result is already rounded. There, that's the exact amount, accurate to 2, 4, 6, 8 decimal places, so we don't need that many decimal places. Of course it's going to be 72 degrees, just approximated or rounded up to, just as that was rounded to 18 degrees. So that's the calculation part. Let's do the layout. Now, laying out this 72 degree angle is fairly straightforward. You grab your kitty protractor and your bevel gauge and set the bevel gauge to 72 degrees, which I have done in this case. There, 72 degrees there, and then copy it over to your block of wood. There, draw your lines. There, there. Okay, fairly straightforward. But we're not done. We're not nearly done. Let me explain two things. There's going to be, okay, three things. The length of the support block is going to be a completely different calculation and different layout procedure in a separate video. Two, there's going to be another angle needed coming from a previous calculation. And three, the 72 degree angle is not 100% necessary to calculate, especially that on the turntable of your miter saw there may not be a 72 degree mark. At the square point, here is a square, there at the square point typically the angle is labeled as 0, and from 0 it goes at 5, 10, 15, 20, 45, yeah, maybe 50 degrees to the left, and the same stuff, 22, 45, 50 degrees maybe to the other side. So that's typically the range of angles printed on the turntable of a miter saw or a compound miter saw. So there is no 72 on it. So what we can do is we can use the 18. Of course we're going to set it to 18 degrees. 18 degrees is a number on the turntable, but it doesn't work if you set the 18, set the bevel gauge to 18 degrees. It's not going to produce this line. So this is where this idea of complementary angles comes in, as well as supplementary angles. Alright, let me explain this thing. So 72 and 18 are complementary angles because they together combine to make 90. In other words, here is the 72 there in this corner, and that 18 there, and this is your 90 degree corner. So this 18 is from the vertical and this 72 is from the horizontal. So it's possible to lay out your angles. Let me just loosen this. Here is vertical. The vertical is 90, and if you go past vertical by 18 degrees, which will be, let me just try to hold it together, maybe tighten it a little bit. There, that's 10% past vertical, sorry, 10 degrees past vertical, 15 degrees, there about 18 degrees is there, maybe, oh, that's too much, just give me a sec here. So, there, 18 degrees past vertical. Vertical was 90 on a kitty protractor. This same angle, now instead of going on the right side of the board, we're going on the left side of the board. See, this angle is exactly the same, and you can lay out exactly the same lines with this angle that's 18 degrees past vertical. There. Now this angle shows up on this, using this kitty protractor, as 108 degrees, because 90 plus 18 is 108. There is no 108 degrees on the miter saw turntable either. But look at this one this way. See there is 70 there. 72 plus 108 make 180. This 180 degrees make this half a circle. Okay, so the 72 and the 108 are supplementary angles because they make 180. And again, here is your 72, here is the 18, and here is another 90. So there's no more new numbers, but keep those ones in mind. and come on over to the miter saw here. There, on its turntable, which of course turns. In the middle, what we've got is 0 degrees. Now this one just happens to be also numbered as 90. So this is 0 degrees for the square cut. That's how it looks like for a square, and we need to cut along that line. So what you need to do, of course, is turn it to 18 degrees, which is gonna be here, that line there, 18. The numbers read from left to right. But there's a second set of numbers on this particular model that goes from 40 to 80 to 90 in the middle, and then it goes down again. So you can see that the 72 mark there, 70, 71, 72, 3, 4, 5, you see this upper scale reads from left, so from right to left. So you set your saw to 18, which happens to be at the same number as 72. There, that's set. And in this case, the cut, when the blade comes down, like so, it comes down exactly along that line that we laid out. There. Now, where is the 108 degrees? Of course, it's here. From this fence to here, it's 108. From the square to here is 18. And the 72 is here. Okay, so for laying out these lines, calculating the 72 is not 100% necessary, but it helps, and I just want to show you how to visualize the 72, the 18, the 108 to make these angles. We're almost done. We're done with laying out this calculation, but there's a second angle. Just hang in there. Where is the second angle on this support block? The other angle that we need to lay out was 2 calculations ago or so, and it's coming from this picture when the rungs of the ladder are tapering. Okay, if you put a support block here like so, it's also gonna be tapering here and here, alright, between the rungs. Let me show you on the real ladder. What I've got is, here is a square, and if I hold it on the underside of the rung like so, you can see that it's gappy there, like so. If you cut the corners just square, the support block will be likewise gappy, not by much because it's not too thick of a wood, it's 3/4 of an inch, 18 millimeters. However, it's still gonna be a little bit gappy just like that, and the defeating kind of the idea of supporting the rung fully or well. So that's another 4-degree angle that needs to be cut on the support block, because let me just put this screen back there, much better, because this angle is a 4-degree angle there, so there's got to be a 4-degree cut at the ends of the support block. So where that 4 degrees laid out, besides this 18-degree angle here, is that this has to be tilted to 4 degrees away from vertical there, and this 4 degree needs to be set on this scale. Okay, I only have one hand, I can't tilt it with just one hand, but it's a compound miter now. It's got a bevel angle, it's got a miter angle there on the turntable, and it also needs to have a bevel angle there. Okay, so that's how you cut on those lines. I've set up here a visual on this 4-degree idea, and you can see the same 4-degree, 72-degree angle combo repeats when it comes to cutting the bottom of the rail. So that's a 90-degree square there, and you can see there's an air gap on the ground between them, which is tapering to a fine point there. So the 4 degrees of course is there up top, and the 4 degrees has to be cut on the bottom of the side rail going sideways, and of course the 72 degrees is here, which needs to be cut either using the 72 itself or the 18, because it's 18 away from the vertical this way, or 18 away from the square there, that way. And one more item that will delight your life with. This is the right side of the ladder, so that's a right 4-degree bevel. On the left side of the ladder there's going to be a left 4-degree bevel. For this reason, and this miter saw tilts left and right. As you can see from the angles, it goes from 0 to 45 left and right, because it repeats on the other side. Now I set it to 4 degrees there, and you can see it's leaning to the left, so that's one of the angular setups. But the other direction, you can see the other gauge, the angle indicator here is now 4 degrees below the 0 into the negative, so it needs to be tilted the other way as well, according to whether you're cutting the right side of the ladder or the left side of the ladder. So just watch out for these degrees. Maybe have a pile of scrap blocks handy. Make sure that your cuts will fit the side that you intend these cuts to be at. Okay, so if you're not doing this on a daily basis, you really gonna have to watch this left and right bevel, because the compound angles change. Okay, they are the same along one side, but it's the mirror opposite along the other side. All right.